All right, you guys can gather around on both sides.
Both sides, okay.
Yes. Both sides.
Oops, sorry, it's just over.
Regina, would you like to participate?
Of course, yeah.
All right, I have 6 stations, so feel free.
3 pairs.
All right, so today we're going to be doing an activity with solutions. First of all, do you guys know what a solution is? Can anyone describe it for us?
Things mixed together.
Things mixed together. That is correct. It's 2 or more things mixed together. And in this case, it forms a homogeneous solution. So all of these solutions are the same completely throughout the whole amount of them. So we're also going to be dealing with density. Anyone else want to describe what density is? You look like it's on the tip of your tongue.
How much of something is in something?
Very, very almost close.
M over V.
Yeah, so basically, to kind of jump off yours, it's like how much stuff is in each unit of whatever you're dealing with. So in this case, we have 3 solutions, saline solutions, so there's salt in them. So the challenge for you today is when I say go for 5 minutes, you are going to stack the solutions on one another. So there is a series, they're not necessarily in that series, of heaviest to lightest. So your job is to stack them and beware of the crack. So how are these solutions heavy? Can you guys describe that for me? How are they heavy? How would one of the solutions be the heavier?
Heavier molecules.
Heavier molecules? Well, they all have the same molecules in them.
They would be tightly packed.
Okay. How so?
There'll be the same molecules, but there's more of them in the same amount of space.
Yes, that's good. Yeah. Did you want to
Just
add?
dense.
Yeah,
Say
that was
that
good.
again. Say that
Yeah.
again. So you have the same molecules, but you have the same size container and you just pack more into it. So there's more of the same molecule making a higher density.
Very good. That's awesome. Okay, so what your task is, again, to stack one of them on each other. So you have these little sealable test tubes. So you're going to take them, and about this much is going to be fine for what our purposes are. So then you're going to, whichever sequence you decide to go, you can all work together in your own stations, but, you know, communicating, or you can work individually and just see who gets it or who doesn't. So you guys can choose which one you want to do. So you're going to take about this much and put it in here, being careful not to splash any out, and being careful to make sure you watch what's happening while it's going in, because you'll see some different things happening based on which we put first. So starting now, see if you can stack them, and I will be able to ask clarifying questions, but I'm not going to tell you the answer.
Can I suggest something?
What?
So, I mean, if we're gonna put one on, hold on. So if that one is the least dense, then it should float to the top. But if we put the other one through it,
We'll see what happens.
do we wanna try to make all of them
So
different
what do you
since
think
there
will
are six
happen? You
combinations?
think that if you put another one on top, you're going to have
Just
that
start
one
this off.
float, if it's the lightest?
Well, I was just thinking we could do all of them differently because
Yeah.
six different.
See how it goes. So, do you guys want pens to write on the paper to see who did which solution first? Oh no.
I don't think so. I think if it's mixed, I think if it's mixed, it's a mistake.
So you can write in front of your station which solution you
So
did.
which one did you do first?
Like which
I did
sequence.
purple first and then green.
Can I write on this?
Yeah,
May I?
of course.
You did purple
And then I added green.
and green. So that's a no.
I'm gonna try the purple and the blue.
So you have purple in there. Oh, you're gonna do purple first.
Yeah.
What happened there?
This one first.
It's beautiful.
So we did purple, green last time, so she used purple blue.
Yeah, so this one was blue first, then green. Also, it's fairly homogeneous.
So, what does that mean in terms of, like, did it work or did it not?
They didn't separate based on density. because they mix together and create a homogeneous mixture, you're gonna simply have some.
Alright. So could you write down which, or tell them which solution you did first?
Yes, so the blue and green.
Okay.
What did you do?
I did the green and then purple. And it seemed to mix. Maybe.
Maybe.
Okay, so let's see how to run that. Cool.
I did the purple and blue, and I also kind of the mixture of things.
Okay, so if you guys get through all of the solutions and see that none of them have stacked, what are some things that you could do to change the variables that aren't the sequences?
Insert it differently.
Yeah.
More
See
general.
if that
How
helps.
John Brown last week. Next Tracy.
For here, sorry.
Wow, look at that.
Should we cover any ways?
So even though that one was less
You can just
dense.
keep it there. We have extra,
Or that.
yeah. And if we run out, you can dump it down the drain. It's just salt and water.
I can see it
Right.
Falling
going
through.
down along the edge and stuff.
Right.
So it's just
It's
a
pretty cool.
slowly.
So blue is more dense.
It kind of looks that way. So,
So should I try mine with
which
Purple
container do we
first?
dump it in here?
Yeah, you can
Always.
waste.
Okay.
Listerine.
If I was pot bottom Pete, I would want to squirt my friends.
Oh yes, be sure to not point them at anyone else.
It's so tempting. It's calling out to me. Please, please, just squirt to me.
That is not safe.
Okay, so.
You guys have one more minute.
One more minute.
Yes, ma'am.
So
I'm going over
this
here.
blue is coming at the bottom of purple too. So I think blue is the most dense.
I agree. Because I can see it.
Does anyone else
going along
concur?
the edge of here.
But I don't know between, what did you get? Green was more dense than purple. Yeah?
green is horizontal.
So from bottom up, it should be blue, green, purple.
All right, guys.
Give us a little more time.
No.
We're almost there.
I'm sorry, this is all the time you get. Please put down the test tubes. You can put the waste in the container and then, wow, beautiful,
Ooh.
Rita.
Ooh,
Look at that
that's cool.
separation.
Ah.
That's nice.
Nice. Okay.
I'm
so
jealous. She
did
did better
you
than I
come
did.
to conclusion on which do you think is heaviest?
Blue. Let's do the blue.
All right, then which?
Green.
Okay, so I came to the same conclusion,
Ooh.
but this was made Friday, so it did kind
Cool.
of separate. But
That's
so
It's like a rainbow.
yeah. So you guys were correct, and I think you did a very good job of coming to that conclusion. So now we have to discuss how this can be applied to our real lives. How do you think you could use this knowledge that you have just gained in the real world? In the real world? In the real world.
Wow. What if something was poisonous and you didn't want to drink it? What was happening?
Yeah, send it back to the poor kid.
So
the
you
poison is
had to
going to the
test.
bottom of your glass?
Right, and then you know it's liquid. Not to drink.
Sorry.
Brigitte, can you please do that? It's beautiful. Good job, but it's time to be done now. That's excellent work. So she clearly had some good technique while she did that. And does anyone else have any ideas on how this is related to not this class? Other than poison, which is, you can try that yourself. You can mix juices in the calf. And how do you see that? Do you think that it's just the concentrate, or do you think it's actual juices? Do you think the juices mix?
I think the juices have different densities, so maybe some of them have different amounts of concentrate.
Have you seen that in the calf? Have you done that?
I haven't done it. I can never make it work, but I know people that do it.
Really?
Yeah.
Okay.
Boss.
Yeah, actually. So, any one more guess of how this might?
Might be taking a shot in the dark with this, but like for medical purposes, like mixing certain medicines and which ones mix the best and
That very
quickest.
well could be. The biggest and most, the biggest use of this is in oceanography. So the currents that you see going through the oceans are more densely packed with salt, and they are generally warmer because, for example, in the blue solution, it's super concentrated, so I had to heat it up and then keep adding salt until there was no more that could be added. Because the higher temperature, the higher the salinity. So this affects weather because the currents transport heat and moisture with them, so it affects the weather on land as it continues through the land. So yeah, does anyone know the most highly concentrated ocean? Little fun fact for the end of the lesson.
The saltiest ocean?
The Atlantic is correct.
Wow.
So what does that mean? Based on what you just learned about the layers of density, what does
The
that
warmest
mean?
and it has the most salt.
Yeah, what else?
And if it has the most salt, then there's gonna be more heat and moisture that will be transported to.
Yeah, good job. It also has the most layers because it has the most salt and so the most difference in the layers as well. Does anyone have any questions for the end of this lesson?
Does the dye change the density at all?
Not significantly. It's a good question,
I was actually
yeah.
thinking about that earlier.
I think this one looks a little more opaque because it has more salt in it, but that's not affected by that. I guess that doesn't really answer the question. So yeah, thanks for participating.
Okay, thank you.